Okay, in this session we're going to talk about merging exponents and roots. Alright, and we're going to start with first converting positive rational exponents into radical form, into simplest radical form. And we've talked about converting the simplest radical form before, but we'll get into a little more detail here. Okay, so we're going to start again with going from positive rational exponents and converting it to, converting that to simplest radical form. Alright. Now, first thing we want to make sure we're aware of is that if you have some number, alright, raised to some exponent, so let's say some number to the 2/3, alright, it may even be better yet, let me just go ahead and, so let's say if it was x to the 2/3, alright, so we'll disregard that and say if we had x to the 2/3. When you have a rational exponent, when we talk about rational exponents, what we mean is an integer over another integer. Alright, so a fraction that has an integer in the numerator and denominator. That's what we mean by a rational exponent. Now, when you have a fractional exponent, what you need to make sure you understand is that the top number represents the power, or better yet, instead of power, top number represents exponent excuse me, and the bottom number represents the root. Okay, so if I was turning this particular example into radical form, again, the top number, the numerator, is the exponent, so that would be like saying x squared, and the bottom number is the radical. Okay, so that's okay, the denominator is the radical, so that would be like saying the cube root. Alright, so my radical and my exponent. Okay, now some people may choose to deal with the exponent first, like we said x squared, then we did the cube root. Okay, but you can also, you could have done this, you could have said the cube root of x, so you could have taken the root first and then said that whole thing squared. So either way you were fine. Okay, so whether you want to take the square first then the root, or if you want to take the root first then the square, it works out the same, just as long as you understand the number in the top is the exponent, number in the bottom, and the denominator is the root. Okay, so let's look at a couple of examples. Let's say we have 25 to the 2/3. Okay, not to the 2/3, excuse me, 3/2. Alright, 25 to the 3/2, 3/2. Okay, so what I can do is I can take the square root of 25, right, because this is telling me that's the root, and because the 2 is telling me square root, versus over here it was a cube root because I had a 3 down here. This is telling me square root. Alright, so I can take the square root of 25, and then whatever I get for an answer I can cube it based on the number in the top. Okay, so the square root of 25 is 5, and then 5 cubed is 125. Alright, so that would be your answer. Okay, alright, let's look at another one. Let's see, let's go with one like this. Let's say we have negative 64 to the 2/3. Alright, so now I can go ahead and say the cube root of negative 64, excuse me. So I want to take the cube root of a negative 64, and this is possible now. We're taking the cube root, not the square root, so don't let the fact that this is a negative confuse you, because we can take the odd roots of negative numbers. It's just the even root of negative numbers is when we get into a problem. So we don't take the square root of negative numbers, but we can take the cube root of a negative number. Alright, so we're taking the cube root of a negative 64, then square the answer. Alright, and the cube root of a negative 64 is, what is that, a negative 4. Alright, then square it, and when we square that, we end up with what? A positive 16, because a negative 4 times a negative 4 squared is a positive 16. Now notice, in this case I had the parentheses around the negative and the 64, so the negative and the 64 are raised to the 2/3. Okay, but now if I switch gears and write it like this, let's say negative 8 to the 1/3. Okay, negative 8 to the 1/3. Alright, that's like saying a negative times the cube root of 8, because now the exponent is just next to the 8. It's not combined with the negative, because the 8 and the negative are not in parentheses like we had here with the negative 64. So in this case, you just apply the exponent to whatever your base is, alright, and then you apply the negative when you finish. So in this case, cube root of 8 is 2, alright, and then you apply the negative on the end, so your answer would be negative 2. Alright, well, here I'll put it like that. Cube root of 8 is 2. You'll have the negative outside, so there, negative 2. There, show you the extra step there. Okay, let's look at some with some variables in them. Let's look at, let's say we have 3y to the 2/5. Okay, now this 2/5 is only next to the y, so it doesn't concern the 3. Alright, this 2/5 is next to the y, it doesn't concern the 3. So this 3 is just going to be multiplied by whatever y to the 2/5 is. Okay, so that's like saying 3 y to the 2/5 is like saying times the 5th root, because the 5 is in the denominator, so that's your root, of y squared, because your 2 is in the numerator, so that's a square, that's your exponent. So that's like saying the 5th root of y squared. So that'd be like 3 times the 5th root of y squared, and that would be your answer. Okay, let's look at another one. Let's say we have x to the 1/4 times y to the 3/4. Alright, x to the 1/4 times y to the 3/4. Notice these two are to the same root. They're both to the 4th root. So what I can do is I can write them both together as part of the 4th root. Now the x is to the 1st power, so that's just like writing x, and the y is to the 3rd power, so that's like writing y to the 3rd. And again, they were both, the x and the y are to the 4th root, so that's why they're both under the 4th root radical. Okay, so this would be your answer in this case. Alright, 4th root of xy to the 3rd power, or 4th root of xy cubed. Alright, let's see. There's another one. X plus y to the 2/3. Okay, now we have parentheses. So these parentheses are telling us that we're taking this whole thing and squaring it and taking the cube root of it. Okay, so the way I would do this, take the cube root of the whole thing, excuse me, squared, right? The cube root, because of my 3, of x plus y squared. There it is. So this would be my answer here, and this was my answer for the last one. Alright, that would be my answer there. So that's really all there is to it. Okay, now what we've just done is taken the rational exponents and convert them to radical form. So now let's go in reverse. Alright, so now let's go from radical form, or simplest radical form, to positive rational exponent form. Alright, positive rational exponent form. We just do a few of these. Okay, well, let's say we have the square root of xy. That's radical form. I want to write them with exponents. Okay, well, both of these are under the same radical, so they're both to the same root. They both have 1 for exponent, because you don't see an exponent there, so that means it's just 1. So this would be like saying xy to the 1/2. Alright, xy to the 1/2, which would be the same as saying x to the 1/2 times y to the 1/2. Either way is fine. Okay, alright, let's see, let's do another one. Let's go with 4th root a to the 3rd b. 4th root a to the 3rd b. Okay, so again, the a and the b are to the 4th root, however the a is to the 3rd. So this would be like saying a, since it's to the 3rd, it'd be like saying 3 over 4, there's my 4th root, the 4, times b to the 1/4. Alright, because b has an exponent of 1, so 1 over the 4th root. So b to the 1/4. And there's my answer. Alright, this is my answer here. Okay, let's look at another one. 4 times cube root of x squared. Alright, so we're going to multiply 4 times x squared to the third root, cube root. So that would be like saying times 4 times x to the 2/3. X squared cube root, that's the 2/3 right there. So 4x to the 2/3. There's your answer. Alright, and one more. Let's say 5th root of x plus y to the 4th. We just did one like this in reverse in the last section. In the last on the last screen. Okay, so this whole x plus y is in parentheses. So we're going to take the whole x plus y. Alright, raise it to the 4th over 5th root. So x plus y to the 4/5. Alright, let me clean that up a little bit. There we go. So equals x plus y to the 4/5. And there you have it. And that's really all there is to this part here. Now, if we're looking to simplify some problems, we can look at a couple to try to simplify. Alright. Let's say we had 3x to the 1/2 times 4x to the 2/3. Okay, and we want to simplify these. We could say the 3 times the 4 is 12, and you have x to the 1/2, and you have x to the 2/3. So that'd be like saying 1/2 plus 2/3, right? Because when you're multiplying, you add the exponents, and 1/2 is like saying 3 over 6, and 2/3 is like saying 4 over 6, right? So you end up with 12x to the 3 over 6 plus 4 over 6, which gives you, excuse me, okay, so this will give you 12x to the 7 6, which is like saying 12 times, what is that, x 7th root of x, wait, excuse me, not 7th root, 6th root, 6th root of x to the 7th, right? Because 7 is your exponent, 6 is your root after you simplify. So there would be your answer there. Okay, that's if you put it in exponential in radical form. If you put it in exponential form, you could have stopped right here as 12x to the 7 6. All right, here let's look at another one. Let's say we have let's see, 12y to the 1/3 over 6y to the 1/2. Okay, and we know 12 over 6 to be 2. Alright, and we have the same base, y and y, so we subtract y and we subtract 1/3 minus 1/2. Okay, so that gives us, and we just said 1/3, common denominator is going to be 6. Okay, so 1/3 is going to be 2 over 6, 1/2 is 3 over 6, subtract, so we get 2y to the negative 1/6. So this y to the negative 1/6, we talked about how if we have a negative exponent, we move it to make it positive. So we can, this whole thing is like saying over 1. So to make this part right here positive, keep the 2 in the numerator and just bring the y down to the denominator. So you get 2 over y to the 1/6 as an answer. Alright, let's look at another one. Let's see here. Let's say instead, now let's look at going from going with the positive rational form. Let's look at the radical form again. So now let's say we have the square root of 2 times the cube root of 2. Okay, square root of 2 times the cube root of 2, and we know we can't multiply the 2's if they're not under the same radical. So what we do is we turn the radicals into exponents. So square root is 1/2, and this is 1/3 because cube root is 1/3. Now we know based on our property rules, the base is the same, so that would be like saying 1/2 plus the 1/3. And we've already talked about 1/2 plus 1/3, where this is saying 2 to the 3 over 6 plus 2 over 6, which equals 2 to the 5 over 6, right? 2 to the 5 6. And then if we take this and put it in radical form, this would be the answer if we stayed in positive rational exponent form. But if we turn it and put it in radical form, then we take the 2 to the 5th, 2 to the 5th, right, under the 6th root. And 2 to the 5th, we know the answer to 2 to the 5th is 32. And then keep our 6th root. That would be our answer there. Okay. Let's say we have one where we have the square root of 5 over cube root of 5. Okay, this would be 5 to the 1/2 over 5 to the 1/3. So this is like saying 5 to the 3 over 6 minus 2 over 6, because it's the same base, so you can just subtract the exponents. So that's 5 to the 1/6. Alright, so 5 to the exponent of 1, 6th root. So 6th root, 5 to the exponent of 1. There you have it, 6 root of 5. Alright, so if you wanted the positive rational exponent answer, that would be it. If you want the answer in simplest radical form, this would be it. Okay, 5 to the first, here's our 5 to the first. 6 root, there's our 6 root. Alright, let's look at one more. Let's say we have 4 square root over cube root of 2. Alright, now all these other problems we've been dealing with common bases, and so I can look at this and say, okay, well 4 can be broken down to a 2 squared, so I can make this a common base. Alright, if I wanted to, okay, by saying this is 2 squared square root, because 4 is 2 squared, over cube root of 2. Alright, and 2 squared square root ends up being 2 to the 2, right? Exponent of 2 over 2, because we're talking about the square root, over 2 to the 1/3. Alright, that breaks down to saying 2 to the 2 is like saying 2 to the first over 2 to the 1/3, and I can turn the whole number 1. I need a common denominator of 3, so I can write that as 2 to the 3 over 3, because 3 over 3 is the same as 1, over 2 to the 1/3. Right, now I have the same base just like all the other problems, like these previous problems, same base. So this would be like saying 2 to the 3 over 3 minus 1 over 3, which equals 2 to the 2 over 3. So that's like saying 2 squared to the 3rd root. 2 squared is 4 to the cube root. Alright, there's your answer. This is the answer in radical, simplest radical form. This would be the answer if they wanted positive rational exponent form. Alright, so that concludes our lesson on combining or merging exponent and roots. If you have any questions, as always, feel free to contact me. We will now conclude this session.